Good afternoon, everybody. My name is Monica Allen, and I'm with NOAA Communications, and I want to welcome all those reporters who are here in the room, and all those journalists who are online, and also our many constituents and people from industry, and some of our private partnerships folks are on the line. So welcome to the call today about NOAA's advancing science through partnerships with private industry and other public entities. We're going to have 4 presentations, as you know, and then we're going to have a Q&A. So we'll save the questions till after that. And so right now I'd like to turn this over to Steve Koch, who is the director of NOAA's National Severe Storms Laboratory in Norman, Oklahoma, for brief comments.
Thank you for joining us today. Today's focus on NOAA partnerships is particularly timely and important, since just last month, Commerce Secretary Wilbur Ross announced the Return on Investment Initiative, which is to improve how we as a federal agency would transfer our technologies or science from the laboratory to the marketplace and to other end users. Today, you will hear about some great examples of how NOAA is successfully collaborating with the private sector, with other federal and state agencies by pooling knowledge, resources, and capabilities. These partnerships are helping to maximize the benefit of the nation's investment in NOAA science and the services we provide. These are my brief comments. I will return this back to Monica to introduce our speakers today.
Thank you, Steve. Now we're going to have each of our speakers give a presentation, and then Anupa Asokan and Anupa is from NOAA Research Communications, will be facilitating the Q&A. And you can, if you're online, you can use the question section there to type in your questions, and Anupa will read them aloud. And if you're in the room, of course, raise your hands and we'll take your questions. We ask that that the press be the people that ask questions for this. And if you have questions and you're among our partners and others who are on the line, please email them to me and I'll handle them. If we have time for some of your questions, we'll take those at the end. But we're going to start with the press today. And I would be remiss if I didn't thank the AGU for partnering with us. This is a very important partnership for us. We work very closely with the AGU on getting our science out, and today they're so graciously hosting us here at their wonderful building in Washington, D.C. And so thank you very much, Nancy and Lauren. Okay, so our first speaker will be Dan Lindsay, who is a senior science advisor for NOAA's GOES-R satellite program in the NOAA Satellite and Information Service. Dan will speak about the next generation of weather observation satellites. Then we'll go to Kelly Page, who's the executive director of the Great Lakes Observing System. Kelly will be speaking about how the observing system is helping Great Lakes municipal water treatment agencies improve public drinking water quality. And then we're over to the East Coast with Diane Capareco, a microbiologist at NOAA's Northeast Fisheries Science Center, Milford Lab in Milford, Connecticut. And Diane's going to tell us about a natural probiotic that reduces disease in oysters. And we will finish up with Ken Fenton, a meteorologist at NOAA's Earth System Research Lab in Boulder, who is developing a way to use weather prediction to increase the safe transmission of electric power and to save money for ratepayers. Thank you, and we'll turn this over to Dan.
Thanks very much, Monica. Good afternoon, everybody. Today I'm going to tell you about NOAA's GOES-R satellite series, Advancing Science with New Technology and Observations, and highlight some of the public-private partnerships as part of the program. You may wonder what GOES-R means. GOES is an acronym, and it stands for Geostationary Operational Environmental Satellites. What that means is we launch these satellites and put them 22,000 miles above the Earth's surface. That's the specific altitude such that as they orbit around the Earth, they orbit at the same rate that the Earth turns. And the advantage of that is they're able to stare at the same point on the Earth at all times, and they're taking pictures, you can think of it as the Earth rotates around. Sometimes the sun is behind and it reflects, that's the daytime imagery, and sometimes it's not, in which case it's nighttime imagery, but we have infrared capabilities to see what's happening at nighttime. I should also say that the first satellite in the series, GOES-R, launched in November of 2016, and it was in checkout for a year, and back in December of 2016, 2017, it was moved over to the GOES East position, where it is now the operational GOES East satellite, and it's providing the primary imagery for the eastern part of the U.S., really the central and eastern part of the U.S., as well as the Atlantic Ocean. This slide shows some of the increased capabilities of its prime instrument. It's called the Advanced Baseline Imager. On the left is the new satellite, and on the right is the legacy old satellite, the GOES 13, the one that was recently replaced. You'll see some significant differences here. For one thing, we're getting full disk imagery. That means the entire hemisphere is scanned every 15 minutes. Compared to GOES 13, the full disk was only scanned once every 3 hours. And so you can imagine how much more information you can get from scanning every 15 minutes. The other thing you notice between these two images is that one of them is in color and one of them is in black and white. And that's another really nice advantage of the ABI. We have more spectral bands, which allows us to make colorized imagery. We can therefore see things like blowing dust, volcanic ash against clouds much better than the previous imager. It's like going from black and white TV to HD TV as an improvement. This slide highlights the public-private partnerships between NOAA, who takes care of the overall programmatic responsibility, as well as procurement of the ground segment, and NASA, who works very closely with NOAA. They take care of the procurement of the space segment, the systems engineering lead, as well as the safety and mission assurance lead. On the private side, we work with a number of private companies some of whom have designed and built the instruments. For example, the Harris Corporation designed the ground system, the Advanced Baseline Imager, Lockheed Martin, the spacecraft, the Geostationary Lightning Mapper, or the GLM, which I'll talk about a little bit more in a minute, the SUVI instrument, and the magnetometer, which are two of the space weather instruments. The United Launch Alliance provided the launch vehicle. LASP, which is the Laboratory for Atmospheric and Space Physics, built the EXIS instrument. It's another one of those space weather instruments. And then finally, Assurance Technology Corporation built the SICE instrument, the last of the space weather instruments. I should also say that the data that's being created or taken by these satellites is being provided to private companies such as TV weather stations, and they are able to show that on television. So there's a lot of partnerships both in the building of the instruments, the delivery into space, as well as the delivery of the data. This slide shows an example of the brand new Geostationary Lightning Imager, or the GLM. This is the first time we've had a lightning imager in geostationary orbit. And what that allows us to do is see the time rate of change of lightning associated with convective storms. In this case, we're looking at an example over the Louisiana area from a couple of months ago. The background image is infrared satellite imagery. This is something you've probably seen from legacy satellites. But placed on top of it is data from the GLM, from the lightning imager. And you can sort of see the flashing motion there, and that is sort of what you would expect to see with lightning, how in the core of the storms you get more lightning, that's where the white area is, and out on the branches and the sort of the other part of the anvil you have less frequent flashes. The GLM can lead to improved forecaster situational awareness and confidence, resulting in more accurate and timely severe storm warnings. This slide highlights another example from the Advanced Baseline Imager, or the ABI instrument. The example that you're seeing here is from Hurricane Harvey, which you may all remember made landfall in Texas last fall. The beginning of the image starts out during the daytime, and then it switches over to the nighttime at the end. You're also seeing 1 minute refresh. That means every image that you see here was taken 1 minute apart. And that allows us to see the spin of the storm in amazing detail, something that we were not able to do with the previous satellite. The final example from the ABI is showing an example of fire detection. This is northwestern Montana from last fall. The red and the yellow areas indicate fire hotspots that are detected by the ABI. And then you can see what looks like smoke, and that's because it is smoke, blowing out from the fires off to the east. You can also see little puffs of convection on tops of the clouds. This is a really nice advantage for our GOES West satellite, which is planned to go into operations in the fall, because it'll have a nice look at the western part of the U.S., which has a big problem with wildfires, as well as Alaska. So in conclusion, I just want to share my excitement with everybody about the new GOES-R satellites, and I advise you to take a look at the Facebook page from the GOES-R satellite, as well as the NOAA satellites Twitter and Facebook feeds and the YouTube pages.
Thank you. Now we're going to go to Kelly Page, who's the Executive Director of the Great Lakes Observing System.
Thanks, Monica. Well, as Monica said, my name is Kelly Page, and I'm the Executive Director of the Great Lakes Observing System, also known as GLOB. We are a 501c3 nonprofit organization and also serve as one of the 11 regional associations of NOAA's U.S. Integrated Ocean Observing System. We were established to support data collection, data management, and data sharing throughout the Great Lakes. And today I'm going to talk about how we partnered with NOAA's Great Lakes Environmental Research Lab, the City of Cleveland, Ohio, and NOAA, a private engineering firm, to help improve the reliability of drinking water for 1.5 million people in Northeast Ohio. So our partnership begins in the summer of 2006. Over a 12-day period, the City of Cleveland's water department was inundated with calls from their customers complaining about the taste, odor, and color of the water. What the city didn't realize at the time is that a combination of different lake conditions were causing this environmental quality of the water to degrade. Though the water was not a public health risk, these complaints were enough of a wake-up call to the city that more information was needed to understand what was happening in the lake, and specifically areas of low dissolved oxygen, otherwise known as hypoxia zones, which are typical in the center basin of Lake Erie, were moving closer to the city's water intake. So we partnered with NOAA's Great Lakes Research Lab to think about, what research was already being done that could help the City of Cleveland better anticipate these changing lake conditions and prepare, any water treatment changes that were necessary to address them. And the first thing we wanted to do was extend their monitoring coverage, specifically by adding a monitoring buoy closer to the water intakes. The issue is that buoys can be expensive, and no single organization really had the capacity to purchase a buoy and then operate it and maintain it ongoing, and then also manage the data. So we worked together. GLOS actually, through a grant, issued a competitive bid for the initial purchase of the buoy. The bid was awarded to NOAA, the private engineering firm. And then after the initial grant funding ended, the City of Cleveland entered into a service agreement with GLOS. And now they pay an annual fee, which covers the cost of deploying, operating, maintaining the buoy, and then also the data management associated with it. We do each year. So just to give you a better picture of what was going on, all of those blue dots are the water intakes that serve the City of Cleveland, and the yellow dots are the buoys. So this dead zone buoy at the top of the screen, that was a buoy that was initially deployed by NOAA's research lab, and it's located more to the center basin of Lake Erie, where the low oxygen levels are more commonly found. Through this partnership, we added the Morgan buoy closer to the water intakes, and that helps give us a better picture of where the hypoxia zone is moving and how it's getting closer to the intakes. And then you'll see a third buoy, LEEDCO. LEEDCO is actually a wind development company, and so they've also contracted with NOAA for the operations of a buoy to help them with their wind farm siting and planning. And then all the the data from all these buoys is publicly available through the GLOS website. So in the first year of the buoy deployment, the City of Cleveland actually ended up making some pretty significant changes to the way that they were treating the water and to roll up this new information and save themselves some money in the process. And all of the partners, involved have also benefited from this arrangement. So NOAA is obviously getting money to operate these buoys, which they're already leveraging to support other clients, and we see that in the case of the LEEDCO buoy. The same group of partners are working together. We're working on developing a weekly forecast model to better predict when and where these hypoxia zones are going to occur and track their movement towards the coastal areas. And then finally, at GLOS, we get to fulfill our mission as the aggregator of federal and non-federal data, enabling a broader use of the data for management and policymaking throughout the region. And we're optimistic that this is going to serve as a model for other local communities who need more data and science to support their decision making. Thank you.
Thank you very much. And now we're going to hear from Diane Caporeco, a microbiologist at NOAA's Milford Laboratory.
Thank you, Monica. Good afternoon, everyone. I am happy to be here today to talk to you about NOAA's Milford Laboratory's partnership with Envera to improve survival in commercial oyster hatcheries. NOAA's Milford Laboratory has been pioneering work on developing probiotic strains for oysters, and we have actually isolated and identified one which we've called OY15. It's a naturally occurring benign strain of Vibrio alginolyticus, a common bacterium found in seawater, and we've isolated it from the digestive tract of eastern oysters. And we've also shown that it improves survival and prevents bacterial disease during aquaculture of the eastern oyster. There we go. So by definition, probiotic bacteria are live microbial supplements that have beneficial effects on the host animal that you feed it to by improving its microbial balance, and therefore improving its nutrition. So what we know already about probiotic strain OY15 is that it's safe for use with oyster larvae. It's safe for use with the microalgae that we feed them with, and we have collaborated with the FDA Seafood Safety Laboratory in Dauphin Island, Alabama, who have confirmed that OY15 is actually safe to be handled by humans in commercial hatcheries, which is a very important factor to consider. We've confirmed that probiotic strain OY15 improves survival of oyster larvae or oyster babies by 20 to 35%, even when they're being infected by a harmful bacteria that could kill them. And this percentage is actually significant because if you're a commercial oyster grower and you have a harmful bacteria entering through your water system into your facility, you could have upwards of 100% mortality of your whole crop of oysters. So if you have supplementing your oyster larvae with our probiotic strain OY15, you still have 20 to 35% survival and still that much more seed to sell at the end of your grow out season. So how does it work? We know that OY15 stimulates the white blood cells of oysters to improve their ability to fight off harmful bacteria. So in the picture on the right, the top large cell that you see is a granular white blood cell that is involved in the shellfish immune response. And these are the ones that I like to call, they perform an engulf and kill process of their immune response. So that's how they're able to fight off harmful bacteria, and OY15 improves that process. So in order to move forward with potential commercialization of probiotic strain OY15 for industry, under the guidance of the NOAA Technology Partnership Office, we entered into a cooperative research and development agreement with Envera to see if OY15 could in fact be cultured effectively and economically in large-scale culture, as well as powder formulations being formed of it, which would give it a stable shelf life and be easy to use for the commercial hatchery workers. Envera is a private company in Westchester, Pennsylvania that's been developing naturally effective microbial probiotic formulations, mostly for the shrimp aquaculture industry for more than 20 years. And more recently, they've been expanding their product line into the finfish and shellfish aquaculture industry as well. The CRADA between the Milford Laboratory and Envera was an exchange of services. The Milford Laboratory has performed specialized analyses to determine immune stimulation of the oyster white blood cells by 10 bacillus strains that Envera currently produces and markets for the shrimp aquaculture industry. They have this catalog of bacillus strains of bacteria that they use for shrimp aquaculture. They wanted to know if any of them could potentially be probiotics for use with oysters as well. And in fact, we did find one strain, Envera 401, that stimulated that engulf and kill process of the oyster's immune function and could be a potential probiotic for oysters. In return, Envera has confirmed for us that OY15 grows effectively and economically in large-scale culture, and they've provided powder formulations of OY15, which we, about a year ago, have tested with oyster larvae, and we have confirmed that these powder formulations also improve survival of the oyster larvae by 20 to 30%. And the next step would be transitioning OY15 to potential industry commercialization, and we would have to reach out to companies to try to make that happen. So to conclude, Milford Laboratories' very valuable partnership with Envera has benefited NOAA's pioneering work on the isolation, screening, and methodology for developing probiotics for oysters as an environmentally friendly way to prevent bacterial disease during oyster aquaculture. Now, why is this important? In 2016, the Food and Agriculture Organization published this graph, which describes world capture fisheries and aquaculture production in 2016. You can see in orange that the capture fisheries production has actually plateaued over the last 30 years, while in teal you see aquaculture production has steadily been increasing to provide seafood to an ever-expanding global population. On the national level, the seafood aquaculture production in 2015 in the United States was valued at $1.4 billion, with oysters and clams being two of the most important commercial species being produced by aquaculture. Now, that $1.4 billion represents only 10% of global aquaculture, and still to this day, 90% of seafood is still imported into the United States from other countries. So clearly, the United States has room to grow and develop the domestic aquaculture product in the United States. So basically, the livelihood of the commercial oyster industry depends on healthy larvae, and the use of probiotic bacteria as a natural method to prevent disease during aquaculture of eastern oysters or any shellfish species for that matter can help sustain the increasing need for seafood production in the world and also improve nutrition and seafood security and provide economic benefits to the aquaculture industry so that we can all enjoy this delicacy on our plates. Thank you.
Thank you, Diane. And now we're going to go to Ken Fenton from NOAA's Earth System Research.
Thank you. Thanks, Monica. I'm excited to be with you today and share with you a passion of mine, which is using weather for better decision making. And in particular today, we'll talk about using weather forecasts for a more efficient electric grid. This is a true partnership between NOAA and its cooperative institutes of CIRA, which is the Cooperative Institute for Research in the Atmosphere, and CERES, the Cooperative Institute for Research in Environmental Science, as well as our partners over in the Department of Energy, Idaho National Laboratory. So what we found is that we can move additional electricity through power lines by using weather forecasts. And this is beneficial because it will increase the safety of power transmission lines, as well as ultimately saving customers money on their power bills. Now, when you think of weather forecasts, you probably think of a 5-day forecast that you see on TV or on your weather app. And in much the same way, we want to use weather information in the hours to a few days ahead time domain to apply it to the electric grid for more efficient power transmission. This is different than the way that the power transmission community is currently operating, because right now they just use one value for the entire season. Now, think if I told you you could only dress one way for an entire season, that wouldn't be a very efficient way to go about your life. And in the same way, it's not a very efficient way to move power around the country by you only using one value of weather for an entire season. The reason that this is important is because there are currently capacity constraints when moving power across the electric grid. When trying to move power from its generation source, be it a wind farm or a power plant, across these long-range power transmission lines to your home or office, there's only so much power that can be moved through at any point in time. You can think of this like trying to move water through a pipe. There's only so much volume of water that can go through that pipe at any given time. And what we're trying to do with these weather forecasts is, in essence, expand that pipe so that we can move more electricity through these same power lines at any given time. The reason that there are limitations in the amount of power that can be pushed through the lines are because of line clearance. And ultimately what happens here is as you push more electric current through a power line, it heats the power line up. And being as it's made out of a metal, typically aluminum and steel, that metal expands, which makes the line sag closer to the ground. As that line clearance between the power line and a ground obstacle, such as a tree or building, decreases, the line can electrically arc, creating a fire between the line and the ground. And what we want to do is increase the safety margin here by providing weather forecasts that will alert them to these unsafe conditions. On this next graph, across the horizontal axis, you'll see days of the year, and across the vertical axis, you'll see the line rating, which is the electricity that can be pushed through the power line measured in amps. The gray bars represent the seasonal ratings, which is what the power transmission industry is currently using. And the blue dots are the real-time rating that we calculated from using observations from our partners, Idaho National Laboratory. The blue real-time ratings represent the maximum amount of power that could have been pushed through the trapped power line at any given time, given the environmental weather conditions that were surrounding that power line. And what we see here is that there's a difference between those real-time ratings and the seasonal ratings, which represents the extra capacity that we could actually push through the power lines given the weather conditions that were occurring around them. And dynamic line ratings will allow this capacity to ultimately be used. And so in order to realize this increase in capacity, we need to forecast the weather, and we want to do so with weather models. The one that we chose for this experiment was the High Resolution Rapid Refresh, or HRRR weather model, which is NOAA's premier regional model, which forecasts weather parameters across the entire continental United States. We used forecasts of temperature, solar heating, wind speed, and wind direction for this experiment. This graph shows time again across the horizontal axis, this time just over the period of 1 day. Across the vertical axis, again, is the electric current in amps that could be pushed through the power lines. And again, that gray bar going across is the seasonal rating that is currently used by the industry. The blue dots, again, are the real-time rating that was calculated from those observations, representing the maximum amount of current that could have been pushed through the line given those weather conditions. The red dots in this case are the weather forecasted ratings of the power line. And here we see that through most of the day, additional power could have been pushed through the lines above what the seasonal ratings allow for, above what the industry is currently using, while also towards the end of the day, improving the safety factor at a time when the weather conditions were not optimal for power transmission. So the end result is that more power can be transmitted with better safety margins and ultimately saving money for the customer. So in conclusion, we found that using weather forecasts will better enable us to make the electric grid more efficient. What this will ultimately be able to do is improve line safety and save customers money on their electric bill. Thank you.
Thank you, Ken. Thank you to all our speakers. And now we're going to open this up for questions from the journalists online and in the room. And if you are online, you can let us know by typing in a question in the question box. And please, we ask that you identify your news outlet and your name if it's not clear. That would be very helpful so we can let everyone know. And Anupa will read your questions aloud, and that will also help us be able to identify you to everyone in the room. So we will open this up for questions. I think we'll start with the room. Any questions from the room? Randy Shostak from EOS.
Thanks for putting this together. So regarding the return on investment initiative, can you tell me more about that and how things will or might be different under this initiative than they have been prior to the announcement of the initiative? And I wonder if, for instance, some of the people around the table could use one or several of the ongoing projects that were discussed today as examples of how they might differ in the future.
Start with you, Ken. Sounds like it's for you.
No, I'm just talking about for Secretary Ross.
Oh, I'm sorry.
Do you want me to
Yes, you
respond to
can
that?
respond to that, sorry.
Yeah, so this came out last month from the Secretary, and really it's about doing better what we have been doing in NOAA already, which is moving our science and our technology into applications or operations, as the case may be, to benefit the American citizenry. So we have many, many examples of doing that. We've seen 3 examples here today of things that are under various stages of development. And the focus here is actually through use of external partnerships, through the efforts encouraging that. The Technology Partnership Office has actually helped us with this at NOAA to build relationships either in the form of formal agreements through such as CRADAs, as we heard about today, cooperative research and development agreements with the private sector, or through other memorandum of agreement or so forth, or just sharing technology and science, that we're actually being able to bring the various sectors together, academic, industrial, and federal, not just within NOAA. NOAA, NASA as an example, one, and many other examples like that. So we could give you many, many examples of that having been done. I think what the Secretary is trying to do is to put greater emphasis on the need to further do this so that it benefits Americans most directly. You know, if they feel that something is benefiting them, and they realize that the science is actually there's actually paying for something that benefits the citizens. I think that's very, very important to get that out. Does that help in any way, Angie?
Yeah, so it's something that NOAA's been doing
We've been doing it
all
for
along.
a long time.
It's just you're putting another emphasis or a different emphasis on
A
it?
greater emphasis. I mean, the Technology Partnerships Office has been funding, kind of encouraging this for a long time. I work at the National Surface Storms Lab. We have a number of these agreements in place. We're helping to move things into operations and into applications in the private sector as well. So it's not new.
Not new, but a new emphasis from the Department of Commerce. So we're happy to have that as a priority. You know, it's been a priority for NOAA for a very long time. It makes sense for us. So now we're going to take a question from online, from the chat line. And Anupa is going to read the question.
This is from Liza Mayer with, I believe, Aquaculture North America.
That's right.
This is for Diane. When do you expect the probiotic supplement to, 1, start commercial production, and 2, reach the market? You mentioned to make this happen, you need to reach out to companies first. Can you elaborate?
Yes, I can, Liza. Thank you for the question. So we are the scientists that have researched and developed this probiotic strain. We have taken it as far as we can at the moment, and what we need to do is reach out to companies who do commercialize probiotic products, and we'll be doing that through the NOAA Technology Partnership Office to try to make that happen. About when it could potentially be commercialized, I can't answer that because it's up to the companies that may or may not want to produce this at the time. We as scientists, we don't know the hurdles that they may experience in their approval process. We're not aware of that. The companies are aware of that. So if it were to go commercializing, in a perfect world, if we had a company that said yes and went forward with it, it could possibly happen in another couple of years. But as I said, we have to reach out to companies to see if they would be willing to do this.
Thanks, Diane.
Follow-up question to that. How and how often do you think the OY15 supplement should oyster farmers need to apply it in their oyster farms, and at what stage in the oyster life cycle?
So we give this probiotic strain, OY15, to oysters during the first 3 weeks of their life. At about 48 hours old, they start to actively feed and actively swim, and that's when we start feeding them this probiotic strain. We know from research that it has to be given every other day to them because it does not last in the culture water or in the larvae longer than 2 days. We know that from research that we have collaborated with at the University of Maryland. They have done these studies for us. So it has to be given every other day for the first 2 or 3 weeks of their life until they actually start to set. That's their most vulnerable time to bacterial disease, to succumb to bacterial disease. So it's just that short time frame to get them over the hump until they set.
And it's in powdered form?
It would be in powder form, yes, at a certain concentration every other day.
Thanks, Diane. Any other questions from the room? Yes, we do. Gabe,
Yeah,
can you identify where you're from, Gabe?
well, I'm local and I'm a freelancer.
Thank you.
I'm not writing for anyone in particular right now. So my questions are for you, Dan, kind of regarding GOES-R. I guess first of all, how many total satellites will be in this series?
Yeah, that's a great question. So there's 4 total satellites in the series. They start out with letters, and that's the GOES-R program got its name because that's the first one, GOES-R. And then so it's R, S, T, and U. And then upon reaching geostationary orbit, they are assigned a number. And the numbers are sequential all the way, starting back in GOES-1, way back in 1975, up until GOES-16 is what GOES-R became. And then when GOES-S was launched back on March 1st from Cape Canaveral, it reached geostationary orbit, and it was numbered GOES-17. And it's currently being checked out. There's plans to launch the next 2 satellites here in the forthcoming years.
They all sit above the U.S.?
Yeah, so what will happen is, the plan right now at least, is to take 17 and move it to the GOES-West position, which is it's technically 137 west longitude, which is the eastern Pacific, but it sees the western U.S. very east, as I said before, covers the eastern part of the U.S., really the central and the east. When the next one is launched, which will become GOES 18, right now the plan is to put it into storage, and it's sort of a backup. If one of them has any problems, they can move the backup over to replace one of the other ones. And then the fourth one will eventually become probably a storage satellite too, and they don't last forever, I think that they maybe have a 10 to 15 year lifetime. And so if one of them has problems, they can bring in the backup to replace.
What's the kind of cost of that entire series?
So the cost of the entire series, if we go back to starting in the early 2000s and going through 2036, which is the length of the program. So what is that? 30 years or so. And this would include everything, procurement, providing funding to the companies to design and build the instruments, launching each of them into space, the ground system in order to process the data. Everything all together is on the order of about $10 billion.
What's NOAA's data policy with these satellites? Is it similar to NASA? Kind of everything is free and open for anyone who wants to use it?
Yep, that's exactly right. Free and open data. One thing I didn't mention is one of the other public-private partnerships is something called the NOAA Big Data Program. And that's a partnership with Google Analytics and Amazon and 3 other companies who are helping put the data on the cloud in order for people to go in and have access to it. And so that's something that just got spun up a few years ago, and it's going to continue. We also, of course, provide the data to our users, the primary users being the National Weather Service and NOAA, but other users as well.
Mm-hmm. So the GOES, 16, you said is already up and operational. That's what we were seeing.
Correct, yes. So some of the images I showed, I think, were when it was in the checkout position over the central U.S., and then when it became operational, they moved it over to the east location where it sits now. And I think that the lightning loop that I showed you was from the east position, which is 89 degrees was the checkout and 75 is the operational position.
Okay. And so if I go on like weather.gov, am I seeing GOES 16 data?
Probably. I mean, if you're looking at imagery over, say, Hawaii, then that maybe GOES 15, which is still the old versions of the old satellite. It will eventually be replaced by GOES 17. But if you're seeing most of the continental U.S. or the Atlantic Ocean, that's going to be GOES 16. Yep.
Had a follow-up question from Liza Mayer. Does the OY15 supplement attack the Vibrio bacteria in particular or any bacteria in general?
The probiotic OY15 supplement sends off a known shellfish larval pathogen that is a Vibrio coriolyticus. That is our pathogen of choice when doing all of our experiments. It's a coral pathogen, yes, but it also is a bay scallop and an oyster pathogen, oyster larval pathogen as well at a little bit higher concentration. So yes.
This one is for Dan from Marcia Smith of Space Policy Online. What is the status of integrating commercial weather satellite data into NOAA's weather models?
That's a good question. That's something that I am not completely sure I know the answer to. So I think I may have to do some research and get back. Maybe she can follow up with Monica and
yeah, please send me an email and we'll work with you on that.
Yeah. I can find some information. Sorry about that.
Thanks, Dan. My email address is monica.allen@noaa.gov. Feel free to email me anytime. That, and we'll get in touch with Dan and follow up. Do we have any more questions from the room? Randy?
Yeah. So this is primarily for Ken, but if others want to jump in, I'd appreciate that as well. I wonder if you can help to quantify for me the benefits of what you're talking about. How significant is it? How much money, how much savings are we potentially talking about? What are the real benefits here, and how quickly is this going to move to be a reality?
Yeah, Randy, that's something that we're actually working towards getting a number for. So unfortunately, I don't have a number for you today. But over the course of the next year or so, we're going to be working with our partners at Idaho National Laboratory, hopefully acquire some additional partners within the Department of Energy and try to get an actual quantifiable number for the savings, either on a local scale or on a national scale for the electric grid.
Any other questions from the room or from online? This is Gabe from freelancer from the area.
So what you showed in your presentation, it kind of looked like maybe imagery enhanced with some other information. I mean, should I think of GOES as sort of like a very high up, wide view Landsat, or what kind of data is it pulling in?
Yeah, so I guess I showed data from two instruments. Most of it was from the ABI, which is the imager. And the best resolution we have from the imager is about 500-meter resolution. And what that means is we can see clouds or other features that have a horizontal scale on the order of 500 meters or half a kilometer. So Landsat, is going to be much higher resolution because it's much closer down to the Earth, and you can get, see things with much smaller scale. But in terms of most weather features, things like clouds, of course, hurricanes, thunderstorms are much bigger than 500 meters. And so we can resolve them very, very well. And we're able to watch the evolution of hurricanes or thunderstorms or even smoke. We saw the example of the smoke. The example of the fire example that I showed was a sort of a combination of multiple spectral bands from the same imager. And so the hot spots you were seeing, they look like flames. We're not actually seeing the flames, but we're enhancing it with the colors based on how hot the fires were. And then the smoke that you were seeing was from the visible bands, and that's basically from the sunlight coming in, reflecting off the smoke and coming back to the satellite.
Mm-hmm. Yeah. So is it comparable maybe to MODIS?
MODIS is a polar orbiter, which means it's closer to the Earth and rotates around and takes pictures, snapshots in time. So you only get about 2 passes a day over a given location. And that way, and for that reason, MODIS doesn't allow getting the loops, the imagery, the movies that we can see. But it does have slightly better resolution because of the fact that it's closer. So they're similar spectrally, meaning similar spectral information, but the difference is the time and the spatial resolution.
Mm-hmm. And how does GOES satellites, how do those compare to what Europe has or other countries?
Yeah, that's a really good question. So this new imager, the ABI, the first 2 of these were purchased by NOAA and by the Japanese Meteorological Agency, JMA, and they launched the satellite with their instrument. They call it the AHI a few years ago. And so we actually were working closely with JMA. We being NOAA was working closely with JMA and they shared the data that they were collecting, and that actually turned out to be a really useful thing because it allowed us to start working with the data ahead of time and learning a lot about it. And then other parts of the world, so EUMETSAT, they launched satellites which covers Europe and Africa. They are planning to launch a new geostationary satellite with a similar imager around 2021 or so. And I believe that China and Korea are also planning to launch similar satellites pretty soon, actually. The Chinese may actually have already launched one.
Mm-hmm. And so those are all kind of the state-of-the-art weather satellites? That's
right. They carry the state-of-the-art instrumentation. And the main thing I'm talking about today is the ABI, is the imager. But some of them will have lightning imagers, much like the GLM, which was the lightning instrument that I showed.
Okay, cool. Thanks. Yep.
And from the chat line?
Okay, this is another question for Diane from Liza. You said that Vibrio bacteria was your bacteria of choice for this research. Yes, why Vibrio?
Oh, I was talking about our pathogen of choice that we used was Vibrio coriolyticus because we know it is a known shellfish larval pathogen. I was talking about it in context of our pathogen.
Is it your bacteria of choice for probiotics?
No. The bacteria of choice for our pathogen, for a harmful bacteria that we challenged our larvae with, was the Vibrio coriolyticus, which is a known shellfish larval pathogen. Yes.
Is it the most common pathogen attacking oysters?
It can be. It was the one that was very newsworthy on the West Coast for killing the Pacific oysters. We were actually working with it before that actually happened in all of our probiotic studies. And Yes, it was the Vibrio coralliticus that was killing the Pacific oysters as well. So, yes, I guess I can say it's a common shellfish larval pathogen.
Do we have any more questions from the line or from the room? I think we did get a question from one person who wanted to know about slides, and we will make those available to everybody in the room, anybody who was on the call. If you need the slides, just we're going to put them on a Google Drive, and so just email me. It's monica.allen@noaa.gov, and I'll send you that after this. Any other questions coming in? Okay, so we also would like to open up now, because we have a little bit of time, to those who are not with the working media who might have some questions. We thank you for joining on a listen only until now, but if you have any questions, we will welcome them now. You can use the chat line. We have a number of folks from the communities that are represented by some of this science. Just wanted to see if anyone had any questions. If not, that's fine. Oh, go ahead.
I'm Joshua Spicer with AGU. I am not a journalist, but I do have a question you brought up today. Is the satellite meant to be a predictive satellite in terms of future catastrophic weather events and things of that nature, or just reflective of what's actually occurring at that time?
Well, I guess the answer is sort of both. I mean, technically, we are capturing what's happening at this time. However, what forecasters use to say what's going to happen into the future, say a few hours tomorrow, next week, whatever, are numerical weather models. And what we do is we take the satellite data and we use something called data assimilation in order to provide that information to the models in order to better inform them what's happening now. Because the model, the better you tell a model what's happening at this exact moment, that when you initialize the model, then the better the forecast is going to be. And so the satellites are providing information basically over the entire globe, especially over the oceans where we have fewer observations. And so giving them more information is going to necessarily improve the model forecasts.
Thank you. I think we are concluding right now, and I want to thank everybody on the line. Thank you for joining us, and everybody in the room. And for those in the room, the AGU has graciously offered some light refreshments, and we welcome you to stay and chat with the scientists and chat with us, and let's get to know you better. Thank you.
When's the rain?
They need to look at the